Can you hear me? Can you see the screen?
Can
Can hear me or not?
hear, teacher.
Right. Okay. Wait for others to come. Okay. 155. Now, in our last lesson, we have seen this problem here. Now, there's a circle, and this is AC is the tangent to the circle. Then there's a right angle triangle drawn, and this right angle triangle has part of the circle in it, and the part of the circle is a sector. And the shaded part is not inside the circle, but outside the circle here, right? This is the shaded part. And we are not going to find the area of the shaded part, but the perimeter of this shaded part. So some of you still cannot understand. So I'm going through this problem again, right? So we look at this one, okay? So this is our problem, and this is the shaded part. The shaded part is A, B, C. Now this one, from A to B, B to C, then from C back to A, this part. Now I have enlarged this shaded part over here on this side. Okay, can you see this side? I'm moving the mouse there. Okay. Now this shaded part consists of three straight lines. Three lines. One is the arc length AB, another one is the straight line BC, and the last one is the straight line AC. Now these three lines, they enclose the shaded area. So if you want to find the perimeter of this shaded area, you have to find the length of these three lines separately. So I'm going to find the length of each of these sides, AB, BC, and AC separately, right? So AB is an arc length, okay? I'm going to find it here. Then AC is the one of the sides of the right angle triangle. So I'm going to find it here. And finally, BC. BC is part of the straight line OC. So I'm going to find it here. Okay or not? So far, can you follow or not? Okay.
Yes, can.
Can. So we are going to find the length of these three lines, AB, BC, and AC. Okay. So first one, I'm going to show you how to find, you concentrate on the mouse, the arrow that I'm moving. First thing we have to find is the length of the arc AB. Okay, right. So it comes from this part here. It comes from this part. Okay, right. So how to find? Okay. The writing too small or not? Is it okay? Can see or not? This writing here. Can. Okay. Now, if you look at this triangle OAC, OAC is a right angle triangle. Now, why is a right angle triangle? Because this line AC is the tangent to the circle. Is a tangent to the circle. So this is a right angle triangle. So the first thing I want to tell you is that OAC is a right angle triangle. Now, OAC is a right angle triangle. Then we look at these two angles here. This angle, theta, which is at the center, and this angle, which is given C. C is given 0.5 radian. 0.5 radian. So these two angles, they are complementary. Have you learned about complementary angles? Yes. So complementary angles, they add together will give you 90 degrees. Now, let's say, for example, if the angle C here is 28 degrees, can you find the angle theta there at the center O? How to find? Because this is a right angle triangle. So if this is 28 degrees, how to find theta? You will use 90 minus 28, 90 minus 28. This angle, 90 minus this angle C here, you will get the angle O. So that means if C is 28, then O is 90 minus 28 is 61 degrees, right? But in this question, the angle C here is not given in degrees. It's not given in degrees. It's given to you in radian, right? So, however, this angle C is not degree, but 0.5 radian. Then how are we going to find this angle O at the center there? Now, instead of using 90 degrees, I will use pi over 2 because I told you to memorize the thing, right? Pi over 2. So pi over 2 is in radian, and this 0.5 is also in radian. So when I use pi over 2 minus 0.5, I am actually finding the other complementary angle in terms of radian. So if I use pi over 2 minus 0.5 and get 1.0708, it means that this angle here is 1.0708 in radians. So that is the reason why I ask you to memorize the table, so that straight away, if you need to use 90 degrees, then your mind can switch. 90 degrees is pi over 2 radian. So you use pi over 2 minus this one, right? So after changing to 1.0708 radian, maybe you would like to find out this angle at the center here in terms of degrees also. So I use this 1.70708 multiplied with pi 180 over pi, and I get 61.35. So this angle is also 61.35 in degree. So I have found out this angle O here at the center here in two different units, in radian and also in degree. So far, can you still follow or not, Li Ying?
Can, teacher.
Can, can. Okay. Now, other students can follow or not? You know why I asked you to memorize 90 to be pi over 2? Okay, yes. So now we find the length here, this length. Okay, so we know this angle at the center to be 1.0708, found out here already. So this is the angle, right? Now, how to find the green line, this green line, the arc length AB. I'll consider this sector OAB. Consider the sector OAB, and we use the formula S equals to R theta. Now, S is what? S is this length, AB, the arc length AB. And R is what? R is the radius, 10, it is given. And what is theta? Theta is the angle at the center. Now, this angle at the center, we have found earlier. So multiply them together, we have 10.0708. Sorry, is it 10 point? Oh, it's 10.708, sorry. Li Ying, am I wrong here?
Yes, teacher.
This is wrong, huh? Okay, 10.708. Okay, right. So this is the length AB. Now, other than this AB, we need to find BC and AC also, but this time there are two straight lines. Okay, so I copy this right angle triangle and put it over here. Right? I put this right angle triangle over here. Can I delete off this diagram here? This one? Delete, huh? Okay, right. Okay, now, right. So this right angle triangle, which I have copied and put over here, right? The radius is given, the angle C is given, and this angle at the center O, molar, I found out in terms of radian, but now I've converted it into degree. So in this right angle triangle, I know the length and the angle. I know the length and the angle. So I proceed to find this line AC. This line AC is this line here, AC. You have any suggestion how to find the brown color line AC or not? Any suggestion? It's a right angle triangle. And the angle is known. Can you still remember Form 3? You learn trigonometry? Tingkatan 3, Form 3. Yes. So you have learned trigonometric ratio, right? So coming back to this right angle triangle, OAC is a right angle triangle. OAC is a right angle triangle. And this length here, AC divided by this length, this is opposite, this is adjacent. Opposite divided by adjacent is tangent. Tangent what angle? Tangent 61/35. Now, when you use trigonometric function, use degree, right? When you want to find the arc length and the area, use radian. You have to remember this, right? Because I told you, this calculator, you have to set in degree mode, right? Set in degree mode. Okay, so now when I use trigonometric ratio, I use degree, right? So move the 10 over. AC, this brown line AC is 10 tangent 61, and using your calculator, 18.305. Is that correct? Somebody please check with the calculator. Sometimes I type wrongly. You know?
Teacher, I get 18.303.
18.303. Never mind. The last decimal place a bit different. Never mind, right? Okay. As I've told you earlier in the exam, the last decimal place difference of 1. Never mind. They still accept. They give you a certain range. Okay, right. So now we have found the brown line and the green line. Next, we are going to find this BC, the pink line. Where the pink line come from? Now we look at the right angle triangle again. The pink line comes from this straight line OC, straight line OC. So we proceed by finding this straight line OC first. How to find OC? Again, we use trigonometric ratio, right? Since OAC is a right angle triangle, and I want to find OC, which is the hypotenuse of the right angle triangle. So this time, I'm going to relate the adjacent with the hypotenuse. So adjacent divided by hypotenuse is what? Adjacent divided hypotenuse is cosine. Cosine of which angle? Cosine of this angle, 61/35. Okay, so 10 divided by OC, 10 divided by OC, which is the hypotenuse, is cosine 61/35. You bring the OC over, bring this cos to the bottom. So we have OC is 10 divided by cosine 61/35, which is 20.86. Is that correct? Someone please check with the calculator. Correct or not? Okay. No answer means correct lah. This one, OC.
Correct, sir.
Correct, huh? Okay. Now we have found OC, but the shaded area doesn't include the part OB. It is from BC. So you look at the diagram here, the OC you have found out, but you only want BC. So you want BC. How to find BC? Okay. Now this BC is OC minus OB. OC, you take the one we have found, minus the OB, then you get the BC. So BC is OC minus OB. What is OB? You look at the diagram here. OB is actually the radius of the circle. So radius of the circle is 10. So you use 20.86 minus 10, 10.86. Right. So you have found out these three lines, this line, 10.078, this line, AC, and also you have found out DC. So if you want to find the perimeter of this shaded area, you have to add up this line, and this line here. Okay or not? Here I typed correctly, 10.7. Here I typed wrongly, here I typed correctly. So answer very accurate, 39.88. This is the answer given in the textbook. So far, any question? If you cannot ask in English, you want to ask in Mandarin, and you speak a bit louder so that I can hear, right? So you can hear, I can answer you in Mandarin. So any question you want to ask? No question. These two girls, no question. Other girls and boys, you can ask in Mandarin. You just turn on your mic, then you just talk to me. I accidentally pressed something wrong already. Can you see the screen?
Cannot, teacher.
Cannot, Cannot, okay. Okay, right, come back here. Can see the screen or not?
Yes.
Yes, okay. So you can see the screen, we continue. Okay, right, this one, no problem. So we move on to the next one. Now, the next question they asked in the Telegram was this question, the city of Washington in United States and the city of Lima in Peru lie on the same longitude, but are on latitude north and south respectively. Given that the Earth is a sphere with radius 6371 kilometer, estimate the distance between the two cities. Now, you have learned about this longitude and latitude in your geography tingkatan 1, I think, or 1 or 2, 1. Okay, right. Now they are on the same longitude, means they are on the same line on the surface of the Earth, the same vertical line, Okay. Now this is the equator, Khatulistiwa, this one, Khatulistiwa. Then above the Khatulistiwa is Washington. How many degrees above the Khatulistiwa? 38.88 degrees. So the position of Washington is 38.88 degrees north. Okay. Then where is Lima? Lima is south. How many degrees south? 12.0 degrees south. That means this Lima is 12.04 degrees below the equator. So the total angle between Washington and Lima, WOL, W here, then O is the center of the Earth, and L. We want to find the total of this angle. Okay, so WOL, the angle at the center is 38 plus 12. Why? Because 38 is above, 12 is below. So the total angle between them is 38 plus 12. which is 50.92 degrees. So the whole thing is 50.92 degrees. But we want to find the arc length. Arc length is S equals to R theta. And the theta has to be in radian. So I must convert this angle 50.92 into radian. How to convert into radian? 50.92 multiply with pi over 180. So it's 0.8887 radian. So someone please check, is it 0.8887 radian? Someone please check and tell me the answer.
Yes, teacher.
Correct. Okay, then we want to find the distance between Washington and Lima. That is the distance, the length of this green line. Now this green line is the arc length. So we use the formula for arc length, S equals to R theta. Okay, S equals to R theta. The R is given the radius of the Earth, 6371. R 6371. Theta 0.8887. Multiply together, you have 5665,662. But the book answer, I think, is 5663. Can someone please check this number correct or not?
Yeah, teacher, correct already.
Correct. Huh? So as I've told you, if the last number, the last digit, not the last number, the last digit, if there is a difference of 1, let's say the answer they gave is, given by them is 3, and we use calculator, we get 2, still correct. Somebody else use calculator, they get 4, still correct. The last decimal place, they allow you difference of 1, more 1 or less 1, they still accept. So don't have to worry, don't have to worry. Okay, not? So far can understand or not? The girl that asked, I don't know.
Can, teacher.
Can, the other girl, I cannot remember her name. Who is it? Jia Yan.
Yes.
Jia Yan or Joey, can't remember. Okay, so this one okay lah. Now we move on to the this question here. This question here is the bicycle. Bicycle, which one is the wheel in front? This one, this one is the wheel in front. This one is the wheel at the back. The pedal is here. So I copy this whole thing over here, okay? So that you can see clearer what is it all about. Now the smaller circle, okay? They have 2 tangents there. One tangent here from this red point to the other side. Then another tangent from this point to the other side. So these two lines here, they are actually tangent to the circle. Maybe I give you a different color so that you know they are tangent to the circle. What color you want? Orange color, okay, orange color, okay. So these 2 lines, they are the common tangent. The tangent common to the small circle and also the big circle. So they have a common tangent here. Now, these 2 tangents from here to here, then on this side is 160 degrees. So again, for the big circle, the tangent here and tangent here. On the other side of the tangent, here, over here, 185 degrees. So do you understand the question or not? Yes or no?
Yes.
Yes. Okay. So one is here 25. The other side here also 25. So this common tangent is given here 25, 25. Now all those that I have written in blue color is given by the question. the values that we find is, I will write in pink color. I will write in pink color like in previously here. You see here, the blue color, the blue color is given by the question, right? It's given by the question. So whatever value I want to find, I will write in blue color, in pink color. Okay, so this is given by the question, right? Oh, time already, they say. Okay, so never mind. Afterwards we log out, then I provide you with a new link and you log in again, right? Later. Still got 10 minutes left. Okay, right. So the diagram shows the chain linking the front and back cranks of a bicycle. It is given that the circumference of the front and back cranks are 50.8 and 30.5 respectively. The circumference, okay? Circumference is referring to the whole circle, not only this part that touches the crank. So again, you see here, the circumference is not only referring to the red color part here, but also the other side. Now, why is it red color? Because this red color here has the chain attached to it. So if you want to calculate the length of the chain, you have to calculate this length here, the arc length here. So similarly, if you want to calculate the length of the chain, you have to calculate the length of this part here. Okay, but you are given the length of the whole circumference. Here also, you are given the length of the whole circumference. Okay. You are given the circumference, but you are not given the radius. So you should use the circumference to find the radius. So the radius in this case is the unknown. So I call the small radius R1 and the big radius R2. Or normally, because if you have two circles or more than two objects of the same shape, we still give them the same symbol R, but you put a small subscript at the bottom there, R1. This one is also R, is also representing radius, but it's a bigger circle, so I call it R2. Okay, so are you familiar with this type of notation? If you are not familiar with this type of notation, then you get used to it, because if you just put R here, R there, people think that it's the same R, which is wrong. It is not the same R, they are different R. Then if you use instead of R, you use X there, Y there, then it doesn't represent the radius anymore. So your mind don't know how to switch. So you still use R for radius, whether big circle or small circle, you still use R to represent the radius, but one of it, you use a subscript R1, the other R2. Now, in this case, the smaller circle, I call it R1, the radius, and the big circle, I call it R2. So you are given the circumference. You are given the circumference. So the circumference equals to 2 pi R. So this is where you make the mistake. Li Yin. You put down there C equal to pi R square. Pi R square is not the circumference. Pi R square is the area of the circle. Okay, not? Okay. So you should use C1 equals to 2 pi R1. C1 represents the circumference of the small circle. R1 represents the radius of the small circle. So you substitute inside here the circumference and you will get the radius. Radius is 30.5 over 2 pi. Don't use the calculator. I'm going to show you this trick here. Okay. Now, in the olden days, during my time, we have no calculator. So if I'm going to calculate this R1 now, and I get a decimal place, I have to truncate the decimal place. Truncate means you potong. So when you potong the decimal place, your final answer will not be accurate. Okay. So what we do in the olden days, during my time, no calculator, we just leave it like that. So the radius is 30.5 divided by 2 pi. Don't do anything, just leave it like that. Jimat masa. Okay, now we look at the second circle. The second circle, again, we say circumference equals to 2 pi r. Okay, so 2 pi r, so the circumference of the big circle, 50.8. 2 pi, then the r is r2. No more r1, huh? Big circle is r2. So what is the radius? Radius is 50 divided by 2 pi. Don't do anything. Just write down 50 over 2 pi. That's all. Just leave it like that. Now, why is it so? We want to find the arc length. We want to find the arc length. Okay, we want to find the arc length. The arc length is this part, the small circle is this part. The angle is 160. So I use the formula S equals to r theta. But because it belongs to the small circle, I say S1 equal to R1 theta 1. Understand the type of notation I'm using? Okay, now you see all the small one, I call it 1, 1, 1, 1. All the big circle, I call it 2, 2, 2, 2. That's all. Okay. So I want to find the arc length here. I know the radius, I know the angle, so I should be able to find the arc length here. Okay, right. Now I go and log out. We log out first. We get a new link, then we log in again. I continue with this part. Okay, because the time 3 minutes left. 3 minutes left. So don't run away, you know. There's still another session. Okay.